Hey everyone, welcome back to our YouTube channel Concepts Decoded. Today we will be starting a new topic called classification. We have learned the working of all the basic concepts of regression. Now we will start the concepts for classification. So classification and regression both belong to supervised learning, but classification is applied where outcome is finite. Now, first concept which we will deal with is logistic regression. So what is it? It uses one or more independent variables to determine an outcome. It tries to find a best fitting relationship between dependent variables and a set of independent variables. For example, let's imagine you have to predict whether a car will go fast or slow based on some features. If the road is slippery, it tends to go slower. And if the road is not slippery, the car will go faster. Now, if a person tells you that cars usually go faster on smooth surfaces, so logistic regression is like using these clues to make predictions. If it gives a number between 0 and 1, so if the number is close to 0, it means the car is likely to go very slow. But if it gives the outcome as 1, it means car is likely to go very fast. So this was the brief about logistic regression. Now let's have a look how we will write the code for it. First, we will import all the necessary Python libraries, NumPy, Matplotlib, and Pandas. Now we will upload our dataset. We will copy the path from here. X is equals to dataset.ilog. Now we will split our dataset into training and test sets. Linear uh, model selection. Import train test split. Extreme. Test size we will take 0.25 and random state will be 0. Now we will print the train test sets to see what we have in our data. X train, Y train. X test and Y test. Now we will do feature scaling. We will import standard scaler from the library processing. Import standard scaler. Initialize variable. We will initialize an object to scale the features. Now x train is equals to se dot fit transform. Fit transform is a method which is used to compute the mean and standard deviation of each feature in training set. And x test is equals to se dot transform. This is used to apply the same transformation in the test set. Now we will print both our training test. Now we will train our logistic regression model on the training set. For this, we will import the model, initializing a variable, and we will fit the model into for the entire data set. Now we will predict a new result. For this, we will write print classifier dot predict. See, so 30 and 87,000. So here the result is 0. Now we are predicting test set results. So for this, y print is equals to classifier dot predict next test. Now here we have reshaped the 1D arrays to transform into column vectors, and we have used the concatenate function so that it adds the two column vectors along the x-axis, and then we have printed it. So now we will be making our confusion matrix, which will store the 4 entries, that is true positive, true negative, false positive, and false negative. So from this we will import our confusion matrix and accuracy score. Name is equals to confusion matrix by test by print. So we have our accuracy as 0.89, and here is the confusion matrix stating the 4 entries. Now the last step is that we have to visualize our results. First we will visualize the results for training set. Here we are inverse transforming to bring the standardized features to the original ones, or to the original scale. Contour F is used to plot filled contours of decision regions. So x1, x2. So here we have made a mesh grid which is used to create a grid of points in a feature space. And here x1 and x2 represent the grid points of the two functions. Now we are making a function called contour f, which is used to plot filled contours of decision regions. X1, x2. Classifier predict. Classifier predict here predicts the labels for standardized coordinates. Dot predict. SC transform here standardize the coordinates. Transform np dot array. We are writing these lines to set the limits of plot to cover the entire mesh grid. So x2, comma, max. Now we will make this loop, which will help to show the which will make the visualization easy with the help of scatter plots to show the data points. Unique I test. Here we have the scatter plot for training set of logistic regression. Now we have successfully implemented the working code for logistic regression. Um, we have this code has demonstrated us first the importing libraries, processing data set, splitting of the data set, printing it first, and then we have learned for how to feature scale our data set. Then uh, we have learned how to create a model, make predictions for predicting a new result and predicting results for test results. We have import confusion matrix and accuracy score, and lastly we have visualized our result using scatter plot. So that's it for logistic regression. Stick till subscribe, like and share our video. Till then, stay curious and keep learning.